Hello. So today we're going to talk about 9.1, which is simplifying radicals. This is stuff that you probably learned in Algebra 1, and we're just going to review a whole bunch of it today as we start in with Chapter 9. So the first thing is just how do you simplify a radical? A radical is another way to say the square root sign. So some of them are really easy. So the square root of 4, for example, is 2. Square root of 16 is 4. But then, if you get into a number like this, the square root of 18 is not a whole number. And sometimes what we would do with that is we would just write the decimal approximation. But other times, we really want to have the actual number. We want to say, well, what is the real answer so that we can compare it to other quantities and make sure that we have the exact answer. So what we're going to do is we're going to simplify this radical. We're going to put it in its simplest form that we can while we still have the exact answer. So we need to look for a square number factor pair of 18. So 18, for example, is like 9 times 2. And since 9 is a square number, that'll work for us. So we're going to take that 9, and we're going to put it outside of the radical sign. And we're going to do that by taking the square root. So 9 square root is 3. 2 doesn't have a whole number square root, so that one has to stay trapped under the radical. And we get 3 square roots of 2. For 32, square root of 32, same thing. We're going to look for a square number factor pair. We're going to use 16 times 2. I know that 8 times 4 is also a factor pair of 32, but we want to use the one with the largest possible square number in it. So 16 is going to work for us. We pull out the 16, it becomes a 4, and we have 4 square roots of 2. For the square root of 27, 27 is like 9 times 3, so we pull that out. 9 becomes 3, and our answer is going to be 3 square roots of 3. 256 is a square number, so when we take the square root of 256, we just get 16. We can also operate under radicals, so add, subtract, multiply, and divide underneath the radical sign. Here we have 3 square roots of 48, and if we're simplifying this, we can think about this 3 as the coefficient. It's sort of just a number on the outside, and it doesn't mean anything to us yet. So we can just rewrite it while we work on simplifying the square root of 48. Well, 48 breaks into 16 times 3. That's its best square number factor. And we can pull out the 16. So we've got 3. 16 comes out as a 4. Square roots of 3. And since these are both coefficients, we can multiply the 3 times 4 together. And we get 12 square roots of 3. All right. Here we've got the square root of 6 squared plus 8 squared. So we're going to treat the 6 times 8 like it is a set of parentheses. So we are going to use the 6 and 8, and we have to actually evaluate them first. So we're going to say, all right, 6 squared is 36, and 8 squared is 64. So the square root of 36 plus 64 is the same thing as the square root of 100. All right, and the square root of 100 is just 10. So 10 is going to be the answer to that. Over here, we've got 2/3 square root of 48. And some people, they freak out when they see a fraction, but a fraction is just another type of coefficient, it's another type of number. So for us, when we see 2/3, we're going to say, okay, we're going to put that on the outside, just like we did with our other coefficient before this. So 2/3 square root of 48 is going to be 2/3 times, we already did the square root of 48, it's 16 times 3. So we pull out the 16, it turns into a 4. So 2/3 times 4 square roots of 3. And that 2/3 times 4 square roots of 3, if we want to make that as simple as possible, we'll think about putting a 1 underneath here. So 2/3 over 4, or times 4 square roots of 3 over 1. 2 times 4 gives us 8 on the top. And when we multiply our coefficients together, we don't multiply our square root in there. So we say 2 times 4, so 8 square roots of 3. On the bottom, we've got 3 times 1, so that's just 3. So we've got 8 root 3 over 3 as the answer there. All right, and then the last one in this row is going to be the square root of 3 plus 6, and that's easy, so that's the square root of 9, which is just 3. All right. Down here we have some rationalizing to do. So if we have a fraction and it's got a square root at the bottom, square root in the denominator, then to rationalize this, that means we don't want to have a square root in the denominator. We're not allowed to have a square root in the denominator, and we need to change that somehow. And the way that we change it is called rationalizing. So to rationalize a denominator, we're going to take this denominator and we're going to multiply it by itself. So multiply it by the square root of 3. But if I want to multiply the denominator by the square root of 3 and not change the fraction, I also have to multiply the numerator by the square root of 3. So in the numerator, I have a radical multiplied by a whole number. So I can't multiply those together. They just sit next to each other. So that's going to be 6 root 3. On the bottom, I have the square root of 3 times the square root of 3, which is the square root of 9, which is just 3. Right? It makes sense that if you multiply a square root times the square root, you get the whole number version. So 6 root 3 over 3 is almost as simple as it can get, but I can also divide the coefficients there, and 6 divided by 3 is 2. So I actually get 2 square roots of 3 as the answer. All right, over here I'm going to do it again. I'm going to rationalize 8 over the square root of 2. I'm going to multiply by the square root of 2 over itself so that I can get rid of that in the denominator. On the top, I just get 8 root 2, and in the denominator, I just get the number 2. And I can reduce my coefficients. 8 over 2 is 4, so I get 4 root 2. All right, these last couple here, we are going to talk about combining like terms, because if I have the same rational part, or the same radical part, I can combine these together. So 7 root 5 gets combined with negative 2 root 5. And we always bring that sign in and talk about that as being part of our term. So 7 plus negative 2 is going to be 5 root 5. When I add or subtract these rationals, I don't add or subtract the number underneath of the radical. I just work with the coefficients. So I've got 5 root 5. And then I have negative 2 root 3 plus 3 root 3. So negative 2 plus 3, it gives me positive 1. So I've got plus root 3 or plus 1 root 3 there. So 5 root 5 plus root 3 would be the simplest way to write that. Here I've got the square root of the square root of 32 minus the square root of 18 plus the square root of 75. I'm going to individually simplify each of those. So we already did the square root of 32. That was 16 times 2. We did the square root of 18. That was 2 times 9. And then the square root of 75. The biggest square number factor of 75 is 25. So we'll do 25 times 3. So this gives us 4 root 2 minus 3 root 2 plus 25, so 5 root 3. And we can go ahead and simplify that one step further. 4 root 2 minus 3 root 2 is going to be 1 root 2, or just root 2, plus 5 root 3. So after radicals today, we're also going to talk about quadratics and factoring, which is another thing you did last year. So these first few are factored equations that we're going to solve using the zero product property. And all that means is we're thinking about what would make this factor into a 0. Okay, so what would make x minus 5 into a 0? It would be if x were to equal 5. So we just basically switched the sign of what we see here. So if x was to equal 5, then the zero product property says that this is going to be equal to 0, which means our answer would equal 0. X minus 2, we would put that as x equals positive 2, because if x were positive 2, this factor would be equal to 0, which would make our answer 0 like we want it to be. Same here, x plus 1, so we have x equals negative 1, and x equals 9, so x equals positive 9. Those would be our two answers. And then over here, we would say, all right, well, 2x minus 4 is going to be equal to what? Or x, in this case, would be equal to what to make it 0? And if we're not sure, we can always write an equation to help ourselves. We can say 2x minus 4 equals 0. And that is us asking the mathematical question, what would x have to be in order for this expression to be equal to 0? So we add 4, and we get 2x equals 4. Divide both sides by 2, and we get x equals 2. All right, if we did the same thing here, 3x minus 9 equals 0, we say 3 times what plus 9 is going to be equal to 0? That's going to be negative 3. So this one would be x equals negative 3. You could write an equation there just the same. All right, so let's take a look at solving some equations here. So to solve these equations, this is also something you should remember from last year. If we've got x squared equals 36, all we need to do is take the square root of both sides, and we get x equals. But remember, every number has a positive and a negative square root. So we need to get out our trusty old plus minus sign. X equals plus minus 6 as the answer there. All right, and that's going to happen every time we need to solve a square root equation. So here we've got x squared equals 40. So we'll take the square root of both sides and we'll get x equals plus or minus. But here the square root of 40 is not a whole number, so we're going to simplify the radical. So if we simplify here, we've got 4 times 10 is going to be the best we can do for a square number factor in 40. We'll pull that out. X equals plus or minus 2 square roots of 10. All right, over here, x squared equals negative 16. Well, if we take the square root of both sides, we're going to be taking the square root of a negative. And we're not allowed to take the square root of a negative. We do that in Algebra 2, but we don't do that in geometry. So instead of writing no solution, a better way to write that would be to say no real solution. The type of solution that it has is called an imaginary solution, but that's something you're going to work with next year. So no real solutions to that equation. And then here, x squared equals 1/9. If we take the square root of both sides, we get x equals plus or minus. And then to take the square root of a fraction, we just take the square root of the top, so that's 1, and the square root of the bottom, so that's 3. So there, x equals plus or minus 1/3. Down here, we've got x squared plus 9 equals 25. In order to take the square root of something, we need to have x squared be the only thing on the left-hand side of the equal sign. So we'll subtract 9 from both sides, and we get x squared equals 16. Take the square root of both of those, and we get x equals plus or minus 4. All right? Same with this one. We've got some evaluating to do because x squared is not the only thing on the left-hand side of the equation. One thing that you cannot do here is you can't take the square root of everything right away. You can't say that this is like x plus 8 equals 10 because this plus here means that that interaction is more than just being sat next to each other. So we actually need to evaluate this first by making it longer. So x squared plus 8 squared is 64 equals 10 squared, which is 100. And now we can solve this equation. We can subtract 64 from both sides. And we get x squared equals 36. And then the square root of 36 is going to be x equals plus or minus 6. All right. Here's a common mistake point that we see. We've got the square root of 11 squared. Now remember that the square root of a number squared is just going to be the number. So the square root of 11 squared is 11, right? Square root of 11 times the square root of 11 must be 11. Plus, and then square root of 7 squared is going to be 7. Equals x squared. That's going to be 18 equals x squared. Take the square root of both sides, and you get 18 is going to be 9 times 2, so that's going to be 3 square roots of 2 equals x. But of course, we have to remember our plus minus, so x equals plus or minus 3 square roots of 2. And the final example for solving square roots here, we've got 2 root 3 squared plus the square root of 8 squared equals x squared. We have a monomial here. It's another word you might remember from Algebra 1. And in a monomial, where we've got parts multiplied together, here we have a whole number part and a radical part, we have to use the power rule when everything in our parentheses is to a power. So we actually have to do 2 squared and do the square root of 3 squared there, because we're using the power rule and squaring both pieces. So 2 squared is 4, and the square root of 3 squared is 3. So that is actually a 4 times 3 term. Plus the square root of 8 squared, which is just going to be 8, equals x squared. So that's going to be 20, because it's 12 plus 8. 20 equals x squared. And then we've got to take the square root of both sides. And the square root of 20 is 4 times 5. And so that's going to be 2 square roots of 5 equals x. But of course we need the plus or minus. So x equals plus or minus 2 square roots of 5. Now we'll get into everybody's favorite, which is factoring. You spent months on factoring in Algebra 1, literally months. So this is going to be pretty much review for you. Might come back to after a couple of examples. So we've got x squared plus 9x plus 20 equals 0. We're going to factor a trinomial. And if you remember, a trinomial is going to factor into a structure that looks like this, where we've got 2 sets of parentheses, x plus something, x plus something. And how we find those 2 numbers is we will look for 2 numbers that add to 9 and multiply to 20. So in this case, if it's adding to 9 and multiplying to 20, the numbers we're looking for are 4 and 5. So we get x plus 4 times x plus 5 equals 0. And then we want to go ahead and switch our signs using the zero product property and say that that means x equals negative 4 and x equals negative 5. All right, over here, same thing. X squared plus 5x minus 14 equals 0. We're looking for two numbers that add to 5 and multiply to negative 14, right? We know that means it's got to be a positive and a negative. So 14's got the factor pair 2 times 7, and if we make the 2 a negative number, then that would work. X plus 7 and x minus 2 equals 0. Adds to 5, multiplies to negative 14. So we get x equals negative 7 and x equals positive 2. All right, coming down here even further, we've got another one. This one's not in standard form yet. We need to change this so it's in standard form. So x squared minus 8x minus 20 equals 0. Then we're going to say two numbers that add to negative 8 and multiply to negative 20. One's got to be positive, one's got to be negative. So we've got 10 times 2. It's going to be negative 10 and positive 2. So x minus 10, x plus 2 equals 0. So that gives me x equals 10 and x equals negative 2. Over here, we're going to do a different kind of factoring that you might remember. We are going to factor using the greatest common factor. So here, the greatest common factor of these two terms is x. So we'll pull out an x, and then we'll open up a set of parentheses and put everything else in there. So we pull an x out, and we get x minus 15 equals 0. That means that we've got two factors. One of our factors comes from this x, and that's just x equals 0. And one comes from this one, and that's x equals positive 15. All right, and then finally, another one that's very similar. We've got x squared equals 8x, but of course we want it to look like this one. So we're going to subtract 8x from both sides so that we can use greatest common factor. So we've got x squared minus 8x equals 0. And then we can pull the x out of both of those. So x times x minus 8 equals 0. And then that means that our solutions are x equals 0 and x equals positive 8. All right, that's all you've got for today. Go ahead and work on the assignment for worksheet number 1 here. All right, thank you so much. Have a good day.